All right, welcome back to our online discussion of math. Today we are talking about permutations in our Scribblecast. We're going to look at evaluating factorials and using permutation formulas, and then using those to solve some related problems. To begin with, just an idea of what permutations are. When I was a youngster, my phone number was 78750. And all you had to do in Lethbridge was call 78750 and you got me. But then quickly we got other numbers, like I remember when 328s came out. And so instead of a 7 there would be an 8. And so then because of that and because of the 381 numbers that came in from the west side of Lethbridge, we had to change our phone number. So now instead of just dialing 78750, I had to dial 327-8750. Oh, was that ever a pain in my neck. I remember my buddy's phone number was 70302. I still remember that one. And but then we had to add this 32 there. And then we had to memorize these other prefixes, which was sort of a pain. Now, and this will date the video a bit, but now they're making us to dial a local number. Instead of dialing 7 numbers, we're going to have to dial 10. So we have to add the area code in front of there. And they're making it so that you can't tell where a person's from anymore, because it used to be 403 was Alberta. Then we got a 780 up north there, but now they're giving us another area code, and apparently now it's a free-for-all. So you could, if you got a cell phone number, you could get it from anywhere. At any rate, we're going to have to dial 10 digits. So start learning how to put numbers into your phone so you can store them and not have to dial all of them. My purpose for bringing this out is that phone numbers are an example of permutations. They are arrangements or orders of numbers in which order is important. For example, 78750, if I had mixed that order up and got 78705, then, that's a 7 in there, although it has the same numbers in it, it would have gone to a different place. Because phone numbers are examples of permutations where order is important. So a permutation is arrangement of objects or symbols into distinguishable sequences. Each unique ordering is called, it's a permutation, and in permutations, order is important. Whoops. Order is important. So if I said how many 2-letter permutations are there using the letters from the word math, where you can't do repeats, well, I'd look in here and say, well, I guess I could put an M there and then an A there, and that would be one permutation. And if I didn't do an MA, if I did say an A then an M, that would be a different permutation. Now, one of the problems we get into is that, yeah, this might be an easy one, that I might be able to put all the ones in that I know, and there might be 12 different ones. But it might be hard to determine exactly how many permutations there are. So what I can do is I can use something called the fundamental counting principle. And we'll see this on a slide that comes up later. But what that does is it says if you have 2 things to fill or 2 events to happen, just figure out how many possible ways there are for this one and multiply it by how many possible things there are for this one. So in this case, I have 4 letters from which to choose to put in the first slot. If I can't use a letter twice, then there will only be 3 letters to use for the next one. So 4 times 3, there would be 12 permutations of 2-letter arrangements using the letters from MATH. Phone numbers. Let's see how many phone numbers I could get. I live in Tabor. 223 is our phone number for most of the people that live in Tabor. We'll see how many people there, or how many phone numbers there'd have to be in Tabor and surrounding area before we'd have to go to another number there. Well, in here, I could probably put in any number from 0 to 9, so there'd be 10 options. In this one, there'd be another 10, because I could repeat. And this one, another 10 and another 10, because I could repeat each of those. So with a 223 designation, 10 times 10 is 100, 1,000, 10,000. So there would be 10,000 permutation or 10,000 distinct phone numbers if I just have 223 dash something. And indeed, any time you have 4-letter permutations, you'd have of numbers, you'd have 10,000 different options. You might have to subtract a couple for police or for some other number that you can't use, but for the most part, there'd be close to 10,000 different permutations or different phone numbers that I could get using this prefix. Now, Tabor's getting bigger. We've got like 6,000, maybe 7,000 people here. I can see the day where, heaven forbid, they might make us use another prefix out front there instead of 223. I guess we're having to use the 403 or area codes all the time now anyway, so okay, just a little bit hard on me. Another way that I could look at permutations is using tree diagrams. So here I'm asking how many arrangements are there for letters A, B, and C. So I could go A, B, C, or maybe I could go A, C, B, or I could go, okay, I'm getting confused. And you can see how you might not be able to remember exactly where you were. You've got to use some kind of pattern. Tree diagrams are helpful for that. So you can say, okay, I could start with an A, then I could do a B, or I could do a C. If I did a B, then my last one would be a C. But if I did a C, my last one, of course, would have to be a B. And those are all the different permutations that would start with the letter A. Let's do the ones that start with the letter B over here. So if I start with a B, then I could have an A, or I could have a C. If I went with an A, my last one, of course, is a C. If I went with a C, my last one, of course, would be an A. So here, there were 2 permutations. Now I've got another 2, and of course with the last one I'm going to have another 2. So up here I could say there would be 6 permutations or arrangements using the letters A, B, and C where you can only use them once. Now in just thinking about that, I could also use the fundamental counting principle, because I have 3 letters, right? How many could go in this one? I could go 3. How many could go in the next one? 2 if I've already used one. And in the last one, I could only have 1. So fundamental counting principle says how many for the first thing, for the second thing, for the third thing, times them together, you get 6. Using our tree diagram, we got the same thing. So this fundamental counting principle, this is what it states. To determine the total number of ways a combined action can take place, combined action, so the 3 letters being put together, I can use the fundamental counting principle. Or determine the number of ways for each separate event and multiply. And that's what the fundamental counting principle says. So for example, here's another one. Jessica, Tanner, Caitlin, Jeff, and Donna are candidates for president and vice president of the swim club. In how many ways could this happen? Well, I want to pick a president and I want to pick a vice president. Fundamental counting principle. Can you see it? So now I just say, okay, how many people could I have in for president? So 1, 2, 3, there's 5. Now if I already pick one president, I can't have him for VP too. Although in baseball they do have managers and general managers that fill the same role. But in this one, no. One president, one VP. Can't be the same person. So if I've already picked a person for the president, I won't have him to pick for vice president. So there'd be only 4 options, having already picked a president. So, with 5 people, there would be 20 different permutations of picking a president and a vice president. Here's another question. I have a new software company, plan to sell at least 50,000 licenses for software. What kind of product key would I have to use so that all licenses were distinct? Okay, well, usually license keys have letters or numbers in them. Let's just see how many. So say I had, say 3. Say I had 3 numbers. So I'm going to put a number here, a number there, a number there. So this event, there could be 10 numbers. I could reuse a number, so I can put 10 there, and I can put 10 there. So if I only used a 3-digit product key, oh, that's not going to be enough. That's only 1,000 different licenses, I need 50,000. Well, okay.